Hello everyone, welcome to Standing Waves by Antonio Aldama and Gonzalo Castañeda. So to begin with, what are the characteristics of a standing wave? A standing wave is limited by notes. As we can see in the first image, the notes are marked by the letter N, while the wave is marked by the letter A. When a wave hits a note, as we can see letter A hitting the second note from the first note, the wave is reflected to the other side, however upside down, as we can see in the image by the dotted line. The second important characteristic of standing waves is that the peaks in which letter A stands do not move left to right, just up and down.
In physics, a boundary condition refers to a restriction or constraint within an equation so that the solution it delivers corresponds with the situation in the real problem. For example, if a car is at rest and starts to accelerate, the equation that represents its motion must include a boundary condition that states that the initial velocity of the car is zero. In the case of standing waves, boundary conditions for the wave equation describe the behavior of waves in certain or limited points in space. Standing waves are present in strings, mostly in strings, that are fixed at both ends. So this means that at both end points of the string there is no motion. So the boundary condition in this case would be that both endpoints of the string have zero displacement at all times. In a standing wave, there are certain points that are standing still. Those are called nodes. In these points, the displacement is minimum, or sometimes it doesn't move at all. Antinodes are the exact opposite. Antinodes are the points in where the motion is maximum. There are many examples of standing waves. The most common example of standing waves are strings. A vibrating string fixed at both ends is the simplest example of a standing wave. This can be found in many musical instruments, in fact, in every string instrument, so guitars and any other instrument that uses chords. Standing waves can also be seen in nature. For instance, when a water wave bounces in a solid surface, it creates a standing wave. Or when two water waves with opposite direction collide, they also create a standing wave.
Finally, we can observe standing waves in nature in a spider's web, as waves that are on the strings of the web are limited by nodes. Similarly, an application of this is that of a guitar. Guitars consist of strings that form standing waves. In order for a guitar to play different sounds, the strings in the guitar must change in length as to alter the wavelength and, consequently, the frequency. This is done by pressing the strings so that the waves cannot pass a certain point.